Well, it's great to speak with you again today, Steve. It's been a while since we've talked, and this is a great topic that you're willing to share with us today regarding logistics network strategy. And could you first share with us how do you define logistics network strategy?
Yeah, that's a great question. It's the simple definition that I would give it is looking at the logistics network, which takes into account the suppliers, all the various types of suppliers and the products that they need to provide, whether they're raw materials or finished goods, and the different shipping methods they would provide that product, and the different origins they provide that product from, and also looking at the outbound side of the business. You know, who are the customers? Who are whether those customers are e-commerce customers or retail stores or B2B type customers where they're shipping to other companies' distribution facilities, for example, or manufacturing plants, for example, and determining based on those inputs of product from suppliers and the outputs of product going to the customer destinations, what is the best way, the optimal way, more appropriately, what is the optimal way to configure that logistics network so that the customers are satisfied and all of those logistics costs are as low as possible without sacrificing customer service levels and things like that. So what that really means, that's a high-level definition, but what that really means is determining, for example, how many distribution facilities should there be, what size should they be, what kinds of functions should happen in those facilities, such as, are they cross-dock facilities, house type, do they have certain activities that take place, value-added services and so forth that take place. But to really optimize all that so that all of the costs associated with the supply chain, including facilities costs, labor costs, equipment costs, inventory costs, and even certain things like utilities and insurance, all these other kinds of costs are minimized in order to achieve the goal, which is to provide that product to the customer. I know that's a long definition, but I think that's really what we're talking about when we talk about logistics network strategy, is how can we optimize those facilities in terms of their location and their size and function in order to achieve the business model for the lowest cost and still maintain the same service levels.
And what types of problems do you face when doing logistics network strategy development?
Well, there are literally, I guess you could say, an infinite number of networks that could be considered, for any given organization, because it's sort of a shot in the dark, right? I mean, if you want to go from your current logistics network to optimal logistics network, facilities should there be or could there be, and then their function and size and so forth. So part of the challenge is really boiling down all of the possibilities to a reasonable number of alternatives that can be evaluated and compared with each other. At the end of the day, what we're really looking to do is model these networks using network modeling software. There's a number of different 4 or 5 major types of network modeling software out there, transportation logistics network modeling software that we can use. But when we model the network, ultimately what we're trying to do is model some reasonable alternatives that make sense to the customer, the client, and give them a pro forma comparison of these alternatives so that when they make these changes to their network over time, their logistics and supply chain network, they're making the best change. And so finding the right alternative to compare is a big challenge. For example, we recently did a network strategy project where the client was really questioning not only where should the facilities be, but should they do their own warehousing and distribution, or should they consider a third party? So that's yet another variable that can enter the equation when you use a 3PL, for example, to manage elements of the logistics network. That creates additional possible alternatives that should be considered. So a big part of the challenge is to really determine what are the best handful of alternatives compared against each other in a pro forma basis to determine what's the best one.
And can you walk us through maybe a few steps, the main steps, and how to set up your strategy and then the implementation?
Sure. It is like so much else that happens with engineering and these kinds of exercises. It is a data-driven exercise, and we've all heard the expression "garbage in, garbage out." So these network optimization projects are heavily driven by data, and if there's not good data to work with, then the results of the analysis are going to be poor. And granted, there are some businesses that may not have a lot of historical data because they're a new business, or maybe there's been some dramatic change in the way the company does business, so they don't have good historical data that they can use in the analysis. But even then, you can make really good assumptions of data. You can use collective wisdom to determine, okay, realistically, what will this network do, even though we haven't done it before. Otherwise, getting that good historical data about how did the network operate over the last full calendar year, let's say, and getting the right numbers that represent, the volumes of product that came in and out of the operation. Also, the growth factors, these are really important because we're not, I typically talk about the past year as year zero, and then the company has to look ahead at some number of years with what I call the planning horizon. How far in the future are they going to plan? It might be 3 years, might be 5 years. That would be pretty common. Some businesses even go 10 years in the future if they're a fairly stable business. And projecting what are our growth factors over that period of time, growth in orders, growth in the number of SKUs that we're going to carry, things like that, because that has to be applied against that baseline data, that historical data or those current assumptions, to project out what those volumes are going to be in that planning horizon, and to come up with reasonable numbers to use in the model. These are the inputs to the model that will help determine what is the best network to support that in the future. So the bottom line is, if you don't have good numbers to work with, whatever alternative you come up with is really going to be meaningless. And so getting that right data on the front end, and then building the model using that data for the inbound and the outbound side of the business. If you kind of consider the business like a black box, and you have the inputs to the business of the product that comes in, the raw materials and finished goods that come in, and then you have the outputs of the business, whatever they deliver to their customers, to run these models using supply chain optimization software to determine, really what's the best way to do that. If you can get past that data issue, that's always the biggest issue. If you can get past the data issue and have data that is either highly accurate historically, or if there's no historical data or limited historical data, if you can have reasonable assumptions about what the future holds on that data, then you can build some really good models, and these models tend to be pretty accurate. The easy part, I say easy, but I think you'll know what I mean. The easy part, once you have the data, is doing the modeling itself, because taking into account things like the shipping rates, the rates associated with full truckload, LTL, parcel, rail freight, air freight, whatever the business uses. Those numbers are easy to get from the different carriers, the rate cards that they would charge to carry the freight. And so once you've analyzed what has to come in and what has to go out in terms of freight, and what is the configuration of that freight, what is the mode and configuration of that freight, then it's fairly easy to calculate the transportation cost of any number of alternatives based on where the facilities in that network will be and what function they will have. Does that make sense?
Oh, yes. My last question is, or do you have any other examples that you could share?
Yeah, they're in these models, in these alternative models that would be compared against each other to determine which one is the best choice. The obvious component of that is freight cost or transportation costs, because moving the product through the supply chain costs money. Secondary to that, many companies would consider space costs or facilities cost per square foot, and then you're looking at certain geographic areas, and you can, based on data that's out in the marketplace, we can determine the cost per square foot of warehouse space, for example, to use that in the model. Many companies might also look at labor costs, because labor costs in a big metropolitan area are probably, for the same type of labor, are probably going to be higher than the same type of labor in a very rural area. So labor costs are often part of the equation. There are many other costs that can also be considered, because if you have to open up a new facility that's a warehouse or distribution center, for example, chances are there's going to be material handling system costs and storage system costs and packaging system costs and all these other types of equipment that might be used in those facilities. And that might be different from alternative to alternative. So they potentially could be built into the model as well. Other forms of costs, like utilities, like insurance, like the carrying cost of inventory, because in a given logistics or supply chain model, you might have different amounts of inventory stored in different locations. So quantifying what that inventory is and what would be the carrying costs associated with holding that much inventory in those locations, that can be built into the model. So the models can be fairly high level and maybe just looking at transportation and freight and so forth, or they could be very granular, and you're going into all different types of costs associated with each alternative model, alternative network that you're considering. Obviously, the more of those things you look at, the more realistic or comprehensive the analysis will be, so that when you weigh it all out and really calculate what is the annualized operating cost of this model at that planning horizon, say 5 years in the future, then you can be more satisfied that you're picking the right logistics network to support the business needs. And that's really what it's all about.
And thank you, Steve. Thanks, Steve, for sharing today. And I'd hope we could stay in touch and follow up and discuss some more topics in the future.
My pleasure. Thanks for having me.